Our first session today is an Oxford Union-style debate about the role of artificial intelligence in peer review. I'd like to introduce the debate moderator, Ruth Pickering, who is the co-founder and Chief Strategy and Business Development Officer at Yewno. Ruth?
Good morning, everybody. First of all, thank you very much for joining us here this morning, and I'm really delighted to be with you all. And this is my first time moderating a debate, so any issues, any mistakes, please feel free to shout out. So the question for us all to consider today is whether AI is key to improving the sustainability of peer review. So I've been very nicely introduced by Melanie, so thank you very much. I won't do that again. But what I'd like to do in this opening session is first of all to introduce the speakers, who'll be representing the two sides of the debate, and then I'm going to explain the format of the session. It is interactive, everybody does need to participate, and I'll explain to you exactly what you need to do and when you need to do it. And then I'm going to set the scene with an introduction, and I'm going to cover the broader topic of AI as that part. So first of all, introducing the two speakers this morning. The motion is that AI is key to improving the sustainability of peer review, and Neil will be arguing in favour, and Angela against. So first of all, let me tell you a little bit more about them both. Neil Christensen is Sales Director, Americas at UNSILO. They provide artificial intelligence tools and solutions to publishers and information services for growing new business opportunities and improving customer experiences and workflows. Prior to joining UNSILO, his experiences span 17 years in publishing roles in Copenhagen, London, New York, Tokyo, and San Francisco, and he's worked with Monksguard, Blackwell, Nature Publishing Group, Wiley, and the University of California Press. He's worked with production, editorial, product management, and business development across many subject domains and product types. And now introducing Angela. Angela Cochran is the Associate Publisher for the American Society of Civil Engineers in Reston, Virginia. ASCE publishes 36 technical journals across all areas of civil engineering. Prior to becoming Journals Director, she was the production director at ASCE, overseeing all production aspects of journals, a monthly member magazine, and book products. She previously served as the managing editor of clinical journals at the American Cancer Society and produced books at Pearson and Appleton and Langer. She is vice president of the Scholarly Society of Publishing and past president of the Council of Science Editors and a regular contributor to the Scholarly Kitchen. So in terms of the format of the session this morning, after my introduction, we're going to all vote. Then Neil and Angela will put forward their arguments, and they're going to have 10 minutes each. After that, they'll have 3 minutes each to counter what the other debater has put forward. And then we'll move into questions from the audience. At the end of the question session, you'll all be asked to vote again, and that will determine the outcome of this session. So hopefully that's what everybody was expecting. So moving on to AI, I wanted to start with this big cloud because AI is a huge term with very, very broad meaning. And it's like saying medicine or engineering. You could be doing a huge range of roles in either of those things, but totally different from one another. So a neurosurgeon, totally different from a gynecologist. And if you look at some of the words in this chart, everything from evolutionary algorithms to fuzzy systems, speech recognition, statistical AI, they're very, very different things. So anybody doing any one of these things or any combination of these things could consider themselves to be in AI. So I've heard a huge spectrum of reactions from publishers in terms of AI. I've seen publishers who are really excited and publishers who are fearful about what AI might do. So however you feel, AI is going to have a huge impact. And I think this quote says it all. It's a quote from the Davos AI panel in 2016. So some of what AI enables is about doing the same things we do today, but more cost effectively. And other areas can deliver completely new capabilities. But overall, the impact to economic growth is going to be absolutely huge. So AI has been in use in our daily lives for many, many years, but it's not necessarily been branded as AI. But you're probably already using it, and you're probably really liking parts of it. So who doesn't find Amazon useful? I actually love my Netflix recommendation service, and things like voice recognition continue to improve. Going back sort of 20 years, Pretty annoying when you got yourself stuck in one of those queues. But now, actually, the tools that we're being offered are actually super useful and can actually help solve your query faster than ever before. So looking outward and looking a little bit at the pace of change, I was quite shocked when I first read these statistics. And today we're here to discuss whether AI is key to improving the sustainability of peer review. But let's look around us at some of the changes that we've already seen in other areas. So in 1965, the average term of an S&P 500 company was 33 years. By 1990, this had dropped to 20 years, and it's forecast to shrink to 14 years by 2026. And approximately 50% of the current S&P 500 will be replaced in the next 10 years. So we can see that the pace of change is massively speeding up. So I wanted to move into more in-depth now and specifically look at AI and neural networks, because AI is all about recreating human intelligence. So a neural network is a mathematical model structured like a human brain and able to simulate some of its functions. In terms of the structure of a neural network, it's composed of several computational nodes called neurons interconnected by a layer structure. A neural network with enough numbers of nodes and layers can understand the characteristics of a complex, nonlinear system and provide guidance on the dynamics of its constituent elements. So before we loop back to the peer review process and start the debate, if AI is trying to recreate human intelligence, what is our brain doing? So different regions of the human brain decompose input into features of different levels of complexity. So looking at this picture here, in the case of face recognition, the brain aggregates simple edge-like features to form more complex face-like ones that trigger the recognition. So I wanted to go back before we start the debate on the peer review process and look at the process itself. And actually, I was looking for the most straightforward thing I could find that would really project well in a big room. And as you can see from this, I haven't done a very good job, but this is actually a really good representation of the process because it is complex. And this was the most simple representation of a very complex process that I could find. So although there are variations, I think this workflow serves as an archetypal view. And as it demonstrates, and as anyone who's been involved in journal publishing knows all too well, peer review is a very labor-intensive process requiring inputs from editors, external reviewers, and of course authors in a lengthy and iterative way. So what I'd like to do now, before I hand over to the two panelists to present their arguments, is ask you to cast your vote onto whether AI is key to improving the sustainability of peer review. And then I'm going to invite Neil to come and open the debate. So is everybody comfortable with this voting thing?
Do we vote too?
You know, I don't know. So I'll give everyone a couple more minutes. If you're having problems, put your hand up. So thank you very much, everybody, for voting. So we have 24 in favour and 16 against. And without further ado, I'd like to hand over to Neil to open the debate.
Yeah. Okay, so that's okay. Sorry about slight delay. So of course I'm for this, and I should say I'm clearly biased, right? I work for a company that specializes in particular in natural language processing and machine learning. So this is how we make our living. The other disclaimer I have is that in a couple of weeks we're launching some manuscript evaluation software that covers some of these features at Frankfurt Book Fair. So, you know, those are my biases on this particular topic. So, machine intelligence in our lives today. I mean, Ruth already mentioned a bit about how this is already fairly ingrained in what we do today, right? I watched a trailer the other day for a new movie called First, or a new TV show called First, where one of the protagonists says fairly early in the movie, or at least in the trailer, believing it when seeing it is backwards, that believing actually comes first, and only then can you see it. And then she says to the other person, I'm asking you to use your imagination. I think what we're debating here today It may be novel, but it's not entirely imagination. But there may be some parts of what we're going to talk about where I'm going to ask you to just sort of step outside and use your imagination a bit. But these are real problems, and these are real technologies that we're going to be looking at. Where did I go? Back here. Let's see here. I'm not accustomed to this. Let me go there. There's hang on a sec. I'm trying to use this mouse here. Okay, so let's try and put our imagination a bit aside and think about the different areas where AI and machine intelligence are involved in our lives today, right? Credit scores, car computing, managing air traffic, job and school applications, commuting, ride-share pricing, and that little thing that tells us the estimated time of arrival, email spam filters, plagiarism detection, fraud prevention, search and recommendations, and personal assistants like Alexa, or in China, the Baidu's Raven. Our lives are really integrated with all sorts of sort of calculations and statistical renderings that happen sort of below the surface. And it's not necessarily a good thing, but for the most part, we don't know how they work. Right? But we still use them, right? Does anyone refuse to get in a car because it contains 10 to 100 million lines of code? No. Does anyone refuse to get in a car because it's software that helps with your anti-skidding control of the car so you don't fly off the road when it's snowy? No. So I'm asking you to think of that in the context of AI and peer review. That it's not that scary a thing, but it doesn't mean that we should just blindly move into this area. We have to think carefully about how we adopt this. And then finally, also consider that a lot of the research that we publish in our journals uses this type of technology to do the research, right? I mean, if algorithms can help with identifying where genes are located in a DNA molecule, I'm sure we can also find some way of using similar technology to help support parts of the peer review process. It's not necessarily a scary thing. There was a recent Publins survey that was released, and it looked at a large global survey of people who help with peer review, and it said that the hardest part for editors is finding reviewers. 75% said finding the reviewers is the hardest part of their job, getting them to accept. Another fact was that 71% of the reviewers say that the most common reason for declining is that they're receiving invitations for manuscripts that fall outside their expertise. There are also other reasons. They don't have time, but this 70.6% was the leading reason for declining. Other things in there, right? 88% of survey respondents believe that training is extremely important for ensuring a good quality peer review. And then finally, there was also an observation, and I think we talked about that a bit yesterday, and it's been talked about quite a lot this year, right? That there's an urgent need to increase diversity in our discipline, and peer review is no exception. So I mentioned these things because we'll touch on some of them when we get into talking a bit more about this. So there are many sustainability challenges in peer review, right? And they have to do with recruitment. How do we find and involve people, right? It's about diversity. How do we ensure that we have a more representative engagement for this process? It's about network utilization. How do we help people find other people at the right time? And it's about culture. How do we change behaviors? Because a lot of the sustainability issues are probably due to cultures that are deeply ingrained in how we do things. requirements. You look at author guidelines. I remember starting in publishing, and an author guideline could fit on a page. Right now, it's 12 pages or so. Right, so we're asking people to check for more things than ever before. And then it's content growth. Of course, there's more content, but it's not just that there's more content. It's also that in the scheme of peer reviewing, we're asking people to assess the context of a given manuscript against an ever-increasing body of literature. So there's more work, and we have limited time. So when we talk about AI for peer review, it's not really about replacing people with an AI. It's about assisting people with things that machines can help with, like spotting patterns across large corpuses of text and data. There's an author called Pedro Domingos who this is one of my favorite quotes, right? Who says that a frequently heard objection is that data can't replace human intuition, but in fact, maybe it's the other way around, that human intuition can't replace data. So the solutions we try and design and build and test for AI and peer review should aim at trying to do the things that machines are good at to support people, not trying to replace people, right? Decisions can still remain in the hands of people, but machines can help look at large amounts of data and make recommendations, sort of like, hey, we noticed this, maybe that's something you want to look at. And it's up to the person to decide if they want to investigate that further, not the machine making a decision. So what can AI help us do today? Well, here are some things, right? Scope matching, journal finder. So does this manuscript match my journal? To which extent? Journal finder, if it doesn't match my journal, which other journals could it match? Editor reviewer finder, which reviewers or editors have the matching expertise for this manuscript? And you can weigh that, right? So I may have some expertise that when someone analyzes my publication history, it shows that I have a lot of expertise in something I did 10 years ago, but the software can also recognize that my expertise has changed. Maybe I changed my research focus in the past 3 years, and there's other stuff I want to do. You can also have feedback loops where you allow editors and reviewers to tell the machine, I understand why you sent me this recommendation or this invitation to review this, but actually I'm not interested in these things. So you can have feedback loops there. Technical checks. Right? In the initial part of the submission process, when things arrive, there are so many things that you want to check in a manuscript to see how things adhere to the author guidelines. Literature reference analysis, I talked a bit about that before, right? There's so much literature now, right? And when we receive manuscripts, we want to review the context of that manuscript in the wider literature, but there's so much to review against. So this is something AI can help with too. Key concept statements. Looking through the manuscript and pointing us to phrases or parts of the manuscript that seem to be central. So maybe you don't need that when you're deep in peer review, but on the initial sort of read-through, that can be very helpful for an editor to sort of quickly assess what is this about. What else? Author keyword selection. Do I get a couple more minutes? Yeah. Author keyword selection. Helping authors select appropriate keywords, terminology screening, looking for terminology in the text to help assess whether it's new, if it's outdated, and then finally metadata extraction. But that's more for publishers. But the idea that you can simply upload a file somewhere, and then instead of having to rekey things into a system, the system can extract it and say, is this correct? If not, can you just make appropriate changes and hit submit, which also is a benefit because it reduces noise and mistakes later in the process. And then many use cases that we have yet to define. Here are just some very brief examples, not to go into any detail, but it's to say what we're imagining is something that is sort of very widget-like, right? And different journals, different publishers, different editors may want different types of widgets that they can use. These are mock-ups for what we're launching in a couple of weeks, right? So it's design mock-ups, don't pay too much attention to what's actually in them. But it's to say this is sort of the one approach to AI and peer review. You can provide people information that sits out there in the margin, and then leave it to people to decide to which extent they want to use that information. And you can have feedback loops. You can learn from the choices they make, whether they actually use that. And of course, you have user sessions with them as well. So AI isn't a magic bullet, right? Technology does not solve all problems. But we can, for sure, use it to address some sustainability issues in peer review, not everything. Growth of content it's a fact, right? And we can see from the recent Publin survey that it is challenging peer review sustainability. So if we don't use technology to try and address some of these, it would just sort of be odd if we didn't. Why wouldn't we, right? We use technology in so many other aspects of our lives. So it's not just about finding more peer reviewers. It's about providing meaningful data to analytics to support some fairly complex decision-making assessments. But it's also sometimes just helping us take care of fairly mundane tasks. And I think my time is up now.
Your time is up.
Yeah?
Thank you. Thank you very much.
There you go. Oh, thank you.
So thank you very much to Neil. I'd like to invite Angela up. And Angela? I'm going to give you 13 minutes because you have 13.
Excellent.
Okay, there you go. I'll leave that there for you so you can see the time.
Okay. When I was in college, I tried to make a point of not registering for a class in which the professor wrote all of the textbooks, because I figured they know too much and there's things that got cut from the textbook that they forgot got cut from the textbook. And so now my new rule about debates is I probably shouldn't agree to do them with someone who's an expert on the debate topic. But I'll give it a shot. Okay, so I'm making an assumption that everyone in the room agrees that peer review plays a vital role in what we do in determining quality research output as well as curating content for specific audiences. And I'm going to talk a little bit about some of the questions. Do AI solutions address sustainability? What could AI help with? What are the pitfalls? And is AI needed to resolve this issue? I'm a skeptic at heart, so sustainability. I want to spend just a minute or two talking about the sustainability in peer review and really sort of question, do we actually have a problem with sustainability of peer review? Are there not enough reviewers or not enough good reviewers? Are there not enough reviewers or are there too many papers? And do our authors serve as reviewers? And that's something that I think is an assumption that is made, that if you're an author, you're also a reviewer. But more publishers that I talk to that are looking at that data are finding that that's not actually the case, that there are an awful lot of reviewers that don't write papers, and there's an awful lot of authors that never review. I pulled from the same Publin's data that Neil did, although I have a bit of a different interpretation. And it is true that editors state that finding qualified reviewers is the hardest part of their job. But one of the things that was also in the survey is that editors are unevenly using individuals as reviewers. And anyone who manages a journal knows that you likely have tens of thousands of reviewers in your reviewer database, and your editors are only using maybe the top 5 to 10% of those people. That they rely mostly on people they know. I think you're getting a call. That's okay. So what the Publin's survey found was that 32.9% of reviewers come from the U.S., but those U.S. authors only account for 25.4% of the papers that we're publishing. And in fact, I know the chart is probably hard to read, but the greenish blue is the number of reviews being done by global region, and white is the number of papers. And the only one that outpaces reviews over papers is the U.S. We have only 8.8% of reviewers are coming from China, but they attribute to 13.8% of the papers, and we know that this is growing. And editors are disproportionately selecting reviewers from their own region. The Publon survey also found that 10% of, what does that say? Publon's data shows 10% of reviewers perform 50% of reviews. So do we not have enough reviewers, or are we just using the same people over and over again? And what can we do to sort of expand the actual reviewer pool, the pool of people who are being used? Editors are sending 2.4 requests to get one reviewer report. This is up 1.9% from the last major survey that was done. But what was really interesting in this Publon's data is that reviewers from established regions are less likely to accept. And as Neil noted, their top reasons for declining was that the paper is outside their expertise or that they're too busy with their own research. But reviewers from emerging regions were found to complete reviews faster. They have a better rate of completing reviews after they agree, and they accept more review requests. So there's an eager audience of experts from emerging regions that are not being used to their full advantage. So is there a sustainability concern, and are there solutions? I would say yes, because editors are reluctant to try new people. But training programs and I think certification and badging, or however they're identified in our systems, of people who have been tried for new reviews, people who have been trained, whether it's bringing in younger researchers or diversifying our reviewer pool to get new people involved and new people trained on how to do quality reviews, and then making that easy for editors to find. Yes, there's a problem because authors aren't pulling their weight. We have to establish rules of engagement. If you're an author, you should be expected to also be a reviewer. We have one journal that actually tracks that. It says right in the acceptance letter, your paper's been accepted, we expect you to do 2 reviews within the next 12 months. And then if that person does not respond to review requests and just ignores our review requests, then the editor sends them a little nudging email. But also because we're not including experts from emerging countries, and we really need to start figuring out how to diversify that pool. So looking at some of the AI solutions that were proposed to try to speed along our peer review process, one of the things, and Neil's gone over some of them, and I read most of the papers and blog posts he's written on this topic before, so we're kind of working off the same playlist, but one of the things is to determine if authors are sufficiently expert on the topic. And I would argue that this disadvantages early career researchers and those that are doing multidisciplinary research. People can change careers, they can collaborate with others, and I think it's difficult to automate a process for determining whether or not someone is qualified to write the paper that they submitted to the journal. Finding excessive text overlap to determine the novelty of a paper. There's a lot of context that's needed to determine the novelty of a paper. And it really depends on what you're comparing. What content are you looking at? To analyze the entire body of literature to provide summaries to reviewers and editors, well, science is often very contradictory. So what does that summary look like if you have 10 papers that say this happened and 9 papers that say, well, maybe not quite that, but then this, and then another 8 papers that say something else? Like, how does the machine learn that there are nuances and there are slight variations? Sources would need to be weighted. I mean, do we really want to look at the entire body of literature? What does that include? And not every discipline reads like a formula. There's a lot of research that says, using the passive voice, the way papers are structured, the way researchers speak to each other is really difficult for machine learning, and that what might be easy in a math journal is next to impossible in the psychology literature. There's just different ways of discussing it. And whether or not a paper fits the scope of the journal, it it can ignore changes in literature, terminology, or emerging fields. I'd say probably of the papers that we reject off the bat, most of them are because they don't fit the scope of the journal. And, but this is a judgment call, and sometimes the editor might be leaning toward expanding the scope of the journal and wants to be open to having new topics represented. AI can help find subject area experts to serve as reviewers. So journals are communities that already have a lot of people involved in them. We just need to make sure that we're using them all. And as my good friend David Crotty says, while subject area knowledge is necessary, it does not automatically make one a good reviewer. AI can help editors determine if a paper will be highly cited. So this is where I get off the AI train completely. First of all, I am opposed to a machine telling an editor that a paper might be highly cited because it biases the entire process. There are no peer-reviewed studies that show that this can actually be done in a way that is any better, and that we'll see negative results being completely discarded, or experimental trials and replication studies, because they don't have a high impact. And again, my friend Tim Vines says the best predictor of future citations is the publishing journal. If you're published in Nature, you're going to have more citations than if you're published in one of my journals. It doesn't have anything to do with the content, it just has to do with where you've been published. Some other concerns I have is, again, that scientific text, not just me, but I've done some research on it, scientific text is an obstacle to machine learning, and I'm concerned about the bias of the machine, which is the known literature. There's holes, and those holes are carried out in perpetuity. And the entity with the most data can manipulate the intelligence. So who has the most data that's being mined, and what were the controls put into determining that? And I worry about serendipity and human curiosity. That is what the scientific method is all about, and I think that once we start replacing what humans are doing in the peer review, and especially the curation process, then we lose some of that interaction. So I would say that it's not resolved, that AI is needed to improve the sustainability of peer review. I'm not sure that it is true that peer review has a sustainability problem. I don't think that AI removes obstacles in improving peer review at this time, but I do think that there's potential, and we need to be looking at things, particularly with discovery. We do need to help editors with discovery. I'm just not sure that our current methods and tacking AI onto it is how to do that. And I believe that human curation is still the best way to determine not only what papers should be published, but also the participants, and in incorporating the peer review process into science. There's a lot of judgment calls that are made, and there's a lot of connections that humans are making that would be very difficult to replicate with AI based on the current literature. And that is my argument. Thank you very much.
So thank you very much to both Neil and Angela. What I'm going to do now is hand back to Neil, who has exactly 3 minutes, and then we're going to swap over, and Angela will have exactly 3 minutes to rebut the other's argument, and then we're going to open up for questions.
Okay. So I'll try quickly to run through some of the things here. So determine if authors are sufficiently experts on a topic. Well, it's fair enough that AI can't find people who haven't written a paper, but that's fairly difficult for people to do as well. And yeah, AI can maybe establish similarity on expertise, but it can't evaluate whether someone will be a good reviewer. But that's also difficult for people if they don't have any experience with that person. So it depends on what data is available. Data isn't available for that, so for now, AI focuses on the similarity match. analyze entire bodies of literature to provide summaries to editors and reviewers. It's tricky. We don't do auto summarization, but the way you do it is you would extract things from a piece of text, and then you would piece it together. So you would use the text itself to create your summaries. Determine if a paper fits the scope of the journal. Angela says that it ignores changes in literature and terminology and emerging fields. I mean, AI can weigh for trends in all of those. In fact, software is maybe in a slightly better position than the average human being to look across, thousands or hundreds of thousands of articles and notice very subtle changes in patterns. But again, as I said before, it's about putting information in front of a person and then letting that person make a determination. Finding experts who could serve as reviewers. I think we covered this one already, and I can see I'm running out of time. AI can help editors determine if a paper will be highly cited. So this is back to impact prediction. I'll leave that alone because I think it's too early for that as well. I know another organization tried to do that a couple of years ago, and then it just sort of fizzled. I don't really know whatever came about it. It's very complex, and I also agree. I don't want to support something where people make decisions on that basis. We already have enough of that, the way people are acting today, so we don't need to reproduce that with machines. So we can avoid that. So it's about what use cases we build for. About passive voice, I spoke to one of our NLP PhDs, and she said that passive voice, is used a lot in research, but you can get around this by not running full parsing on it, right? So you lemmatize and you stem the sentences. You don't necessarily understand them, in a linear fashion, and that's the way you get around to it. Yes.
Thank you very much, Neil. Now I'm going to hand over to Angela.
Not sure I have 3 minutes worth of rebuttal, but I'll give it a shot. Human authors model their papers for human readers. There's a lot of nuance, there's a lot of expectation of what you may previously know, and quite frankly, we're requiring that authors not repeat a lot of information. We're asking them to refer back to other works that they've done or others have done. And replacing this process or augmenting this process with too much AI can put authors at a disadvantage in the beginning because some of those nuances may go missing. But also, over time, it trains them to game the system. So most of us probably use, a similarity check software. And the same company that does a lot of our similarity check also has a service for authors where they can pay and basically do the same search that we do and could tweak their paper enough to get it below the threshold that we're looking for. So if there's a will, there's a way. And it wouldn't take that long for authors to change how they're putting their papers together in order to game the system when they know what's being automated and what's not. When it comes to expertise, some of the things we've done a lot at my organization, we've done a lot of trying to tease out certain expertise. This is part of our taxonomy projects, and we have a taxonomy on content, but we also have an expertise taxonomy for authors. And we've tried a couple of different products to do this, or partners to do this. And one of the things we find is that if an author wrote a couple papers about, let's say, remediation of cadmium from the soil on a Superfund site, the system always wants to call them an expert in cadmium. And this is not what that author would pick as their expertise. They're an expert in remediating hazardous waste from the ground. So there are some nuances even with determining what the expertise of human beings are. And just looking at the titles and the abstracts or even the full text of their article may not make that clear. Not all text is standardized and not all scientific literature is in English. wow, it's not all in English. So let's just maybe put the passive voice a little bit to the side and also say that if we're feeding information into a machine to try to learn what the patterns are and the summaries are, it's going to have to be able to read it in Farsi and in Persian and in Chinese, in multiple different ways of Chinese, in Spanish, in Portuguese, because to not do that ignores an entire huge global body of literature. Thank you. Huh. That was amazing.
So thank you very much. Sorry. Thank you very much to both our panelists. And what we'd like to do now is open up the debate. So there are microphones in the audience. If you'd like to raise your hand if you have a question, and then be clear if it's for either Neil or Angela. Thank you.
Hi. I don't know if you can hear me. I'm Anna Jester from Regional Press, and my question is definitely for both of you. To what amount do you feel that the bias of algorithms, as discussed both in books like Weapons of Math Destruction and also more recently even by Sophia Noble at SSP, what are you going to do to help be aware of that constantly and continually adjust algorithms for AI?
Hello? I think it's all about the design process, right? So you put these features out there, you want to test them, you want to have, long periods of testing and evaluation with the people who are going to use them before you make them commonly available, right? And I think it's about maturing our capabilities, right? So we have to acknowledge that when we first try and do things, often we don't get it exactly right, but we can be aware about the things that we need to look out for in the process, and then we can work with the people who are going to be using the systems to ensure that they need to work in ways to, say, avoid bias. But I do want to say on the issue of bias, we also have to be aware that a lot of machine intelligence, it's about bias, right? Because what we do is score and rank content. And so for you to make that type of scoring and ranking and filtering, you're automatically sort of at the foundation of what you're doing, you're working with a biased process. That can be problematic, but I think it's simply a foundation of everything we do, and maybe in particular in the peer review process, right, where bias is used to select things. But what we need to do is, of course, is to root out all the things that we don't want to port over, that we already know are problems, right? And we've acknowledged that we need to address. I think in sort of intelligent collaboration between developers and the people that use the systems and the people that are affected by the systems, we can design systems that do their best at sort of accelerating these existing problems. But we probably can't entirely root them out because they're deeply ingrained in our existing human behavior, in our literature, right? So some of it will port over, but let's just be aware of it and not avoid the discussion.
So there's definitely concerns about bias in peer review and in the human process as well. And everybody's bringing whatever their it could be their subject area bias. It could be other more concerning biases having to do with gender or where the authors are coming from. But the thing about having humans doing it, and it's not perfect, but typically you're going to have 3 or 4 people involved in peer reviewing a paper. So there's often a chief editor, there may be a section or an associate editor, there may be 2 or 3 reviewers, and they don't all come with the same bias. So there is a bias, and that may be good or may be bad depending on what the bias is, but it's not the same for all people. When you turn it over to an algorithm that's controlled by one entity, there's one massive bias that's not necessarily being countered or mitigated or filtered through multiple people.
Great. Are there other questions?
I'll
Oh, yes?
Just a quick follow-up, right? Yes, there is a massive bias, but for this type of stuff, we have to realize that bias is represented in our literature. And we have to remember that this is not, it could be, at least that's not what I'm suggesting today. It's not a matter of the machine making a decision. It's a matter of doing some analysis of large bodies of text and data, putting it in front of those three people, and then letting them make their decisions. So it's not taking that away, right, from people.
Thank you. I think there was a question on this side of the room.
Is there a question?
So just looking at the practical process, work process of peer review, is it your position, Neil, that you would actually be eliminating some of the steps? I mean, is there a reviewer step that would be reduced here?
No, absolutely not. I think our position is that we should try and use machines where it's meaningful and where it's possible to support the tasks and steps that already happen. And there will be tasks and steps where we're like, no, we're not going to do that because it's just not meaningful, or we're not producing like a valuable outcome by doing that. I think it's very important for this process, and I agree with Angela that there has to be an opportunity for some curiosity and serendipity in the process. I think that's very important. So ours is more like use machines to analyze data, some data parameters, and put them in front of people. You know, you as a reviewer and editor, you may have run a number of searches to try and qualify something. How does this fit in the context of the previously published literature? And that could have taken you a very long time, and you could have arrived at a fairly random result. The machine will help you do that. It doesn't remove your responsibility to use, you know, your experience, your brain to evaluate, but it may help flag some things that you would have missed normally in your own sort of analysis of large data.
Thank you. Angela, would you like to say anything? No. Great. So back to questions. We have a question over here.
Yeah, I guess this is more for Neil. So as I recall the resolution, it was AI is key to making peer review sustainable. And Angela brought up some interesting notions about the question of sustainability being relating to some cultural issues in the peer review system, that some of which may not be amenable to automated solutions. So going back to the original resolution, I was hoping you could argue for why AI is key to making peer review sustainable in the sort of, in the most extreme version of the resolution.
I don't like to talk in extremities or in extreme scenarios. I mean, I think it's key because I think the data, the response that we're seeing in things like surveys, but also in our own experiences, working and publishing, is that people are pressed for time. These are real issues, right? Editors and reviewers that cram something into, 2 hours in the evening after they've done everything else, and then they try to get a review out. I think that may impact quality of review. It may not. That may depend, right? It's clear that the processes that we use today to find reviewers are a bit circular, right? People tend to look in the same networks of people they know, and there's a utilization issue there that we're not necessarily involving enough people in this process, and those are things that AI or machine intelligence can definitely help address. So as I said, I don't think it's definitely not a magic bullet, right? It just isn't. But given that we're having some serious issues about turnaround time, about recruitment, about diversity, it just seems to me that if these are the types of problems that we're having, then we should definitely look at to which extent can we use machines to help us with some tasks, not all, but are there some things that we can help people do so they can spend 2 minutes less on doing that, or 1 minute less on doing that, or they can avoid inviting, the 2 wrong people and spending 3 days doing that. And then at the end of the day, all the decisions that are going to be made are still going to be made by humans. It's just trying to provide them with some automated analysis of some of the parameters that we know that they look for. And only those parameters that they've confirmed themselves in prior research that they'd be interested in maybe seeing some data on to help them make decisions. So, sorry, it wasn't really extreme, because I don't feel extreme about the topic, but I do think that it can address sustainability issues.
Angela, anything to add? Okay, great. So we have a question here from Stephen, and I see a question over there. Anyone else with questions? Okay, so 3 more questions. Stephen, you go first.
So, Neil, you mentioned in one of your rebuttals there that you didn't feel that the machine was making meaningful decisions. I wrote it down because I thought it was interesting. You said the machine is not making meaningful decisions. Maybe I misunderstood. But my point is that if the machine is making meaningful decisions, let's just accept that it is. We have huge examples in the public world, Facebook and Google, of machines making really bad decisions that are very, very meaningful through exclusion. So that's why I don't think it can be key if it is meaningful. If it's not meaningful, then I don't see that it can be key. Almost by definition, if it's not meaningful. So my thing is that today, AI is not there. Mainly because if it were there, I think we'd see a lot less fake news from people like Facebook and Google.
So I don't know, maybe I misspoke or something like that. I think we have to be careful not to look at something like Facebook or Google or other examples that we can find and then just port it to AI and peer review. I think in AI and peer review, the things that we're looking to do, at least what we're looking to do, are very specific and targeted and applied. I just don't. I don't see. I see that we can be fearful about where AI can go, but when we look at the actual use cases of what we're trying to do, I don't think we need to fear.
So your argument is it's meaningful?
Yes, AI is.
What about the bias?
Well, as I said, in which case, what about the bias?
Exclusion?
So AI can help find the people who have published on the topic before that editors apparently aren't finding today.
I'm going to have to wrap that one up there, but I'm going to pass over to a question on my right.
Mine's actually very related to this too. It's I completely see your point, Angela, about how people are biased and the literature is biased. Absolutely, it happens a lot. But I'm also wondering, certainly related to that question too, is it possible to train the AI to try and help us counteract our own inherent biases by highlighting different things and pointing out when the result that's coming up is probably a result of bias?
I don't know from a technology standpoint about training machines and algorithms around the biases. I'm not familiar enough with how that would work, but I would be highly skeptical of it. I just think that there's not enough information. It's not clear from the way we're publishing journal articles or the scholarly literature, however we want to define it. It's not clear to me that there's enough information provided there to counter program for those biases. I have, and then you take sort of these pieces of information and augment the peer review system so that an editor has all these other little pieces of information around them, but you don't know who's vetting those pieces of information. So, if it's a summary, is it a good summary? Does it actually include all the literature? Does it only include Elsevier journals? Does it, what is the scope of this information that's being put in front of the editors? We ask authors, or we do a check to see, has this paper, and we ask the authors, has this paper been submitted to one of our journals before? And most, we're looking for, yes, it was rejected by this journal, and I was told it was out of scope, so now I'm going to this journal. And we had an editor that said, can you ask them if it's ever been rejected by any journal, and which journal it's been rejected by? And I said, no, because now automatically you're thinking this is a crap paper. And that's not the bias you should bring to it. You should give the author, a fresh start. And so, I'm concerned about how things like corrections and retractions are accounted for when there's a scan of the literature. It's not always clear that a paper has been corrected or retracted. So it's not clear on our websites. It's not clear in any of the indexing databases. So, how exactly do we do that? Is all of the literature being put forth on the internet in the same way? Is it all XML under the same general DTD and easily scannable for machines to learn by? And we know that answer is no. So, my concern continues to be that there's not the format in which we make this information available and the wide variety of how the scholarly record is published would not allow for enough information to do that kind of counter-programming.
Thank you. So moving on to our final question.
Sure, I think there's actually another question.
two more.
But Neil, it's really for you. I was curious, you said for us to use our imagination, but have there been any pilots or test cases where it's worked? Where it has cut down on time and the editors feel that it's really helped in terms of the peer review process?
So yes and no. I mean, some of these things have been tested. We've tested some of them, right, but hasn't been public. The things that have been tested are things like Reviewer Finder, and they help. It definitely opens up the scope for people discovering other people that they wouldn't normally have discovered. The other features that I mentioned are ones that we are releasing in 2 weeks' time, right? So this is why I say use your imagination, because it is very new. And I can guarantee you that out of those features that we have up there, 12 months from now, they'll be named differently. Some of them will have been removed. We'll have done some testing with some editors and reviewers, and they'll say, have you considered, can you give me the data in this format instead? That would be helpful for me to make a decision. So they'll be tweaked as well. So that's where the imagination comes in. It's we have the technology to do some of these things, and it's very early, right? I think we're going to look back 10 years from now, and we're probably going to laugh at some of the things that we're proposing today. But that's how evolution works. That's also how it works in the research we publish, right? It's evolution of knowledge. So this is fairly this is the front line, at least for us in terms of AI in peer review. It's fairly new.
Can I add a comment?
Yes,
Yeah.
of course.
With all due respect to my co-debater here, I think peer review of the scientific literature is way too important to throw new ideas out that haven't been tested and see what happens. Facebook, Twitter, were thrown out there with, let's see what happens. And there are huge social ramifications that neither Facebook or Twitter or Google gives a crap about. And I think that we need to be very careful with that. And so while this is all very new, I think we need to move very slowly and take baby steps into incorporating some of these things into the peer review process.
Thank you.
And
So moving on to our final question, I believe.
I have to agree that selecting reviewers is the biggest problem for peer-reviewed journals. And AI can be a tool, not a takeover of your decision-making. It's very helpful when you get a list of relevant reviewers, suggested reviewers that AI can do, complete with the reference of their work that is closely related to the manuscript, and then the editor makes the choice. But it's better. It's a lot better than my memory.
And I should say, I completely agree. This is not something that we just want to throw out there. I mean, what I imagine the process is that you have some ideas and you test those ideas, and when the ideas work out or don't work out, or they are iterated to the point where people feel, I could actually use this a bit more in a day-to-day, that's when you release them, right? So when I say, we're releasing this next, in 2 weeks, I don't mean we're releasing it to the general public. I say, we're going to make this available to publishers so we can start that piloting and experimentation process together with editors. And then it could be months yet, right? Some of the features we know, that we can comfortably do today, and some of them we can't. But we have to start. We have to start somewhere, right? I mean, think about how many people are not struggling, are spending valuable time doing review. I think we owe it to them to come up with solutions that help those people who are spending their free time to do very, very valuable work. Not by throwing solutions at them that throw away 150 years of evolution in how we do those things, but by giving them some more options to get rid of some mundane tasks, or provide them with some oversight to help them make their decisions that they had before, but it required a lot of time and effort for them to look through the same amount of content.
Thank you. So thank you to everybody, and thank you to everyone in the audience. So what I'd like to do now is to ask you all to vote again. It's exactly the same process as before. Details are on the screen. We'll give you all a few moments. No need to rush.
And note that that is a different URL, so you can't let it auto-complete from the last time.
So is anybody still looking to vote? Has anybody's vote not been captured? So this is an interesting outcome. Oh, can you not see it? That's interesting. Doug, what am I doing? I'm clicked into this, but it doesn't appear to be projecting. Thank you. So this is a very interesting outcome, and I feel that I should have gone on a slightly more extensive training course on the Oxford debate rules. So the way the rules of this work are that you start off and you do your initial vote, and the results, i.e. the winner, it's not the person with the highest score, it's the person with the highest change. So if we look at this, we started off with 60%, or 24 votes for the motion, and we started off with 16 votes against the motion. And now we've ended up with 22 votes for, so it's actually reduced by 2, and we've still got 16 for. So I think, Melanie, you're going to have to correct me. If I'm correct, it would be the against.
Actually, refresh.
Oh.
I think it's the other tab you want to look at.
Hang on. Oh, no.
It's like the Academy Award.
Which one then? Hang on.
Click on the other tab at the top.
This one here. That one. Okay. Okay, oh, it has changed. So we've got 26. We had 24 for, now we've got 26. And we've got 17 against. So that's interesting. So more people have voted the second time round. Is that fair?
Maybe some people arrived that weren't.
Okay, we're going to have to go with the flow. So Neil went up by 2, Angela went up by 1. Thank you very much to both of our panelists, and thank you very much to the audience for participating.